Hello friends, welcome to my channel Maths Tutor Lakhyajit, and this is part 2 of mathematical physics paper solution of BSc first sem mathematical physics paper 2021, right? And in part 1 we have solved from question number 1 to question number 4a, and in this video we are going to start from question number 4b, right? Question number 4b. And the link of the first part 1 is given in the description box, so if you haven't watched, you may go through. Okay, so now let's start. And before we start, please subscribe the channel if you are new to my channel, and share with your friends, and also hit the bell icon so that you get notified when new video will be uploaded. And if you like, then hit the thumbs up button and inspire me to create new contents for you. So now let's start. So this is question number 4b. Here, solve the following first order linear differential equations by using integrating factor. So any two, we have to solve any two of these three equations, so using integrating factor. Now first order linear differential equations, those are of the form dy by dx plus px, sorry, not px, py is equal to q, where p and q are the functions of x only, so or maybe constant, right? So here what we're going to do, the process is very simple. So first we are going to find the integrating factor, that if is equal to e to the power integration p dx, right? P dx, then our solution will be y into integrating factor is equal to integration q into integrating factor plus constant c, right? So this is the solution. So now let me show you how to solve this. Now let me show the first one. So here is the first equation. So as I have told you that this is of this form, dy by dx plus py is equal to q, and where p and q may be constant or functions of x only. So if you compare with this equation of if you compare with this form py is equal to q, this given equation, then you will get p and q, and integrating factor will be given by e to the power p dx, and solution is, as I have already told you, that y into if integration q into if dx plus c. This is the solution here. Comparing with this equation, the first equation with this, we got p is equal to x, q is equal to x. So this is p and this is q, right? So hope you have understood this. So therefore integrating factor e to the power p dx, that means x dx, right? Here p dx is p is x here, so that's why x dx we have written. And if you integrate this, what you're gonna have, x to the power 2 by 2, right? This is our integrating factor. So solution should be given by y into integrating factor. Here integrating factor is e to the power x square. So we have got this integrating factor here, this one, e to the power x square by 2. So this is the integrating factor we are going to put here. So then we get the solution, so integration e to the power, sorry, q into q is x here, this q is x here, so we have put q is equal to x to get the solution, e to the power x square by 2 dx plus c. So this would be our solution, right? So now let us integrate this part. So then what you will get, integration x e to the power x square by 2 dx. So put x square by 2, x square as t, okay? So put x square is equal to t. So now if you differentiate with respect to x, you will get twice x dt by dx, and x dx is equal to dt by 2, right? So now this solution, this integration becomes integration e to the power x square by 2 dx. It can be written as half e to the power t by 2 dt, right? So what we have done, we have substitute x square by t, right? Putting x square is equal to t. So that's what we have done, okay? And x dx, here x dx is dt by 2, and this half is taken out of the integral. So hope you have understood this part. So now if you integrate this, what you're gonna have, that half e to the power t by 2 divided by t by half, because you see integration of e to the power mx dx is given by e to the power mx by m, right? So we have applied that one. So you have understood this. Now here this half cancel, right? And is equal to e to the power t by 2. So t is x square, so you will get x square by 2. Now if you put this one, if you put this value here, you see, if you put this value of integration, result of this integration here in this solution, then you will get the solution. Y is equal to e to the power x by 2, e to the power x by 2 plus c. So this is your solution of the first one. This is the required solution. Right. So hope you have understood this. Now let us solve the next question. Next equation is our dy by dx minus y by x is equal to twice x. So let me write the next equation. This is the next equation, right? Again compare with this dy by dx plus py is equal to q, and this is the solution of this equation, right? So e to the power p dx is nothing but integrating factor, right? So if you compare these two, if you compare this given equation with this, then here you see is this second term minus y by x. This can be considered as minus 1 by x into y. So this is the value of p, right? This is the value of p, and qx is here twice x. If you see this q twice x is q, right? So now let us solve. So this is p, this is q, right? So integrating factor e to the power p dx will be equal to e to the power minus 1 by x dx, and minus integration of 1 by x is log x, and here you see e to the power log of anything is equal to that thing. That means if you have suppose e to the power integration, not integration, e to the power log x, then you can write directly x, right? So remember this. So e to the power, so here as we have minus sign here, so as you have minus sign here, so it can be taken as log x to the power minus 1, because you know n log m, that can be written as log m to the power n, right? So we have used that logic. So then what you get here, x to the power minus 1, which is 1 by x. So the solution is y e to the power p dx integration q into y e to the power p dx plus c. So now you see, let's put the value of this integration first, value of this integrating factor, right? That what we have got, that is 1 by x. Let us put here. q, value of q is twice x, right? The value of q is twice x, so we have put here, you see this is q, so we have put here twice x, right? So now, and e to the power p dx is nothing but 1 by x, so dx plus c. Now x gone here, you can see clearly, and now one here you can write dx only, right, plus c. Okay, this 2 is taken outside the integral, so that's why you have got this. Now integration of dx is nothing but x, right? So we have got y by x is equal to twice x plus c. So this is our solution, right? So this is the required solution. So hope you have understood this. Now let's move on to next question. So this is question number 5. Here the function of x and y are given here, so we need to find those. Del f by del x, del f by del y, partial derivative of f with respect to x, partial derivative of y with respect to y, then again second order partial derivative also with respect to x and y of this function f, right? So first let us write the given function. First one, that is f of x and y is equal to x to the power 4 minus twice x square y square. So here you see, let us find del f by del x first. So if you differentiate this with respect to x, then partially, if you differentiate it with respect to x partially, then keep the y constant, right? You have to take y as a constant, right? So remember that. Then if you do so, then what you will get, 4x cube and 4x, then y square remains y square as it should be considered as constant, right? Then second order derivative of f with respect to x square will be what that will be obtained by differentiating again this result, right? Because we have already got del f by del x. If you differentiate it again, then you will get the second order derivative, partial derivative of f with respect to x, right? So again, keeping y constant, if you differentiate, then you're gonna get 12x minus 4y square only. So similarly, let us find del f by del y. So now keep x as a constant, then differentiate this given expression, given function, then you're gonna get minus 4x square, right? Because derivative of this x to the power 4 will be 0 with respect to y, right? So that's why we have got then again, if you differentiate the second term, here you see we have minus sign here, so that's why here it is minus sign. If you differentiate this this x square should be considered as constant, then differentiating y square, you will get twice y. The 2 is multiplied with this 2, that gives 4, right? So that's why what you have got now, if you clean this, let me clean this first. So we have got this result, minus 4x square y. So what we have got, minus 4x square y. We have differentiated this function keeping x constant. Now as we have already got del f by del y, and to get the second order partial derivative of this function, again differentiate this result with respect to y, keeping x constant. And if you do so, then what you will get, minus 4x only, minus 4x square. So we have already got this 4 results, del f by del x, then second order partial derivative of f with respect to x, then derivative of f with respect to y, then second order partial derivative of f with respect to y. So we have got all these 4, right? So now let's differentiate the second function also, this second one. So we have got all these 4. So now next function is given, this one. Now you can proceed same way, del f by del x. So you're gonna get this, keep the y constant. So we have differentiated this keeping y constant with respect to x, then again differentiate this result, then you will get the second order partial derivative of f with respect to x, right? Again keep y constant, right? Then now we are to find del f by del y. Now differentiate this keeping x constant. Now we are going to differentiate with respect to y, keeping x constant, and in that case what you're gonna have, this derivative of this will be 0 because this is function of x only, right? And derivative of this second term will be what? Minus 6 x square y to the power 5, right? Here we have kept x as a constant. Now as you have got del f by del y, if you differentiate this one again, then you will get the second order partial derivative of f with respect to y. So on doing so, what you will get, 6 5 are 30 x square y to the power 4. So this is our result. So this is question number 5. Now let's move on to the next question. So this is question number 6. Here solve the following partial differential equations by the method of separation of variables. So we have to solve these equations by the method of separations of variables. Here let me tell you one thing. So here you see you have du by dt and du by dx, sorry not d, del u by del t, del u by del x. So that's why this function, this should be u of x and t only. So there is a printing mistake, that should not be y. Okay, so now let us continue. So here you see this is the first equation, right? This is suppose equation number 1. Now let us consider u, that is function of y and x, is equal to capital X of small x dot y of small y. So we have taken this one as equation number 2. So we have taken that u is a function of x, product of function of x and y, that product of two functions respectively functions of x and y, like that we have considered. So del u by del x will be x dash, and t should sorry not t, here y, it should be y, this should be y, y should be capital Y, should be kept as constant. Then del u by del y, so x should be taken as constant, so it should be y dash, right? So now from equation number 1, from this equation, if you use these values of del u by del x and del u by del y, if you put these values, then this equation number 1 becomes thrice x dash y plus twice y x dash, sorry x y dash. So these are capital X capital Y, okay, is equal to 0. Now you see what we can do here. If you simplify this and if you separate the variables, then you will get this expression, right? Let it be equal to k, okay, let us say this is k. Now you see what you can do here. You can equate x dash by x is equal to k, right? 3x dash by x is equal to k. Now you see x dash represents del capital X by small x, that means derivative of capital X, which is a function with respect to x, okay. So that's why you can write this one as d capital X by d small x by x is equal to k, which can be written as 3 1 by x dx, sorry, 1 by capital X dx, not dx, d capital X, and k small dx. You can write in this form, right? So now, so what I have done, I have written this equation in this form first. So just do it. So now you see, so let what we have done here. So now I have written this way. So because here you see capital X dash means ddx of capital X, right? So you can simplify this equation in this form, right? So then what you will get, just wait. now you see, now you can integrate both side, right? If you integrate both side, then what you will get, just let me write this one properly, just wait, sorry for this. Okay, so now you can write this above equation, this one in this form, right? Now let us integrate both sides. Then what you will get, integration of 1 by x is log x, so log of capital X. Then on the other side, k by 3 is constant, so integration of dx is simply x, then plus, and let us take the constants log c1. Now here you see this can be written in this way, k by 3 x small x. So here you see this one is small x and this one is capital X, right? So this is capital X, log of capital X, and this is small x, this one is small, right? Remember that. So now you see, you can write e with this term k by 3x, you can write log e, because log e will be 1, right? Plus log c1. So you see, if we know that this property n into log of m, that's gonna give you log m to the power n. If you use this property here, then this term will be power of e, right? So hope you know this. So now, so what we can do here, it can be written as log of capital X is equal to log e to the power kx by 3, right? Plus log c1. Now here you see, now here we're gonna apply in this step log m plus log n, that's equal to log m into n. If you apply that rule, then what you're gonna get, so you will get this, right? You will get this. Now removing log from both sides, capital X is equal to c1 e to the power kx by 3, that's what you will get. So now you see, using the same pattern, if you equate this part, minus 2 capital Y dash by capital Y is equal to k, then what you're gonna have, so if you use the similar pattern, a similar method here, so you can find, just wait, let me clear this. Okay, then you can find this with minus 2 capital Y dash by Y is equal to k. So capital Y is again d capital Y by d small y, that means derivative of capital Y with respect to x, that's it. And using this, you can write the above equation in this form, right? You can write this way, right? So now if you integrate and compare this one with just if you integrate, you will get this, right? After integration, and if you compare this result with this, okay, so then you can see we have got capital X is equal to c1 into e to the power kx by 3. So where we have got kx by 3, this term is kx by 3. So if you compare this result with this one, with this result, you will get, instead of this value here we have minus k by 2. So and instead of c1 we have c2. So that's why we can write capital Y is equal to c2 into e to the power minus ky by 2 using the same pattern. So that's why we will write y is equal to c2 e to the power minus ky by 2. So we have got capital X and capital Y. Now let us use these values. Here you see, if you use these values in equation number 2, in this equation, so in this equation number 2, if you use the value of capital X and capital Y, then you will get the result, then you will get the solution, capital X into capital Y. That's capital X is c1 e to the power kx by 3 and c2 that is capital Y, value of capital Y is c to e to the power minus ky by 2. So this can be simplified as c1 c to e to the power kx by 3 minus ky by 2, right? So this is your solution. That's how you can solve. Now let us solve the next question. So this is the next equation here, right? Again, this is equation number 1. Let its solution be y u of x and t is equal to, suppose, capital X of small x dot capital T of small t. This is equation number 2, suppose. And let us find del u by del x, and x dash t will be constant, then del u by del t, that in that case x should be kept constant, t dash. So now use these values in equation number 1. From equation number 1, if you use these values here in equation number 1, then you will get this, right? Now let us simplify it. So it can be simplified in this way. Right, let it be k. Now we can write this part is equal to k, as well as this part is also equal to k. Let us take the first part first. So x dash minus x by x is equal to k, suppose. So it can be simplified as this. So now x dash means, just take the x common. Now x dash means, what does it mean? As I have already told you, that this is the derivative of capital X with respect to small x. That's it, right? And if you use that, what you're gonna have? So I have already told you that this x dash is equal to d capital X by d small x. Now you see, if you put x dash is equal to d capital X by small x, then this equation will take the form of this 1 by x capital dx k plus 1 dx. And if you integrate this, so integrating this equation, you will get log of capital X k plus 1 and x plus log c1, right? Integrating this, we have got this. Now you can see, we can write this as k plus 1 x log of e, as log of e is 1, so plus log of c, then it will becomes this. So here it can be written as x is equal to c1 into e to the power k plus 1. If you simplify this, here you see, so here you can write log of this one plus log of this one, as you can write log of c1 e to the power k plus 1 into x, right? And if you remove the logs from both sides, then you will get this result. This should be x. Now let me clean this part here. So what you're gonna have now, you can equate this part. 2 t dash by t is equal to k. If you take this part, you will get this, right? Now again, if you integrate, you will get this result. Then t is equal to c2 kt by 2. So what we have done, we have compared this result with this, right? With this result. After getting this result, we have got capital X is equal to c1 e to the power k plus 1 into x, which is this one, k plus 1 into x. So that's why here we have got k2 by k by 2 into t. That's why here c2 e to the power k2 by t. Here we have taken the constant log c2, right? So we have got capital T and capital X. So use this value here in equation number 2. So we will get the result. This is equation number 2, and value of capital X we have got this, and capital T we have got this. Now put these values here and simplify, then you will get this result. So this is your result. That's how we can solve. So hope you have understood this. So this is our third equation. So let it be equation number 1, suppose. So now let us solve this. Let us take again u, that is a function of x and y. Let it be product of two functions, that capital X of which is a function of small x, and capital Y which is a function of small y. And let us suppose this is equation number 2, right? Let us suppose this is equation number 2. Now just a little bit of adjustment. Okay, now you see, let us find del u by del small x. If you differentiate this with respect to small x, so this is the function of small x, so you will get x dash, and capital Y here it should be considered as constant. Capital Y should be constant as it is partial derivative, right? Then del u by del small y, so this is the function of y, then y x should be considered as constant now, so capital X y dash, right? Now use these values in equation number 1. So using those, what we will get, this equation number 1 becomes this, right? You will get this. Now you see, if you separate the variables, then you will get x dash by capital X dash by x, and 4 y dash by y, and let it be equal to suppose k. Now you can equate this x dash by x is equal to k, as already we have discussed that that x dash, this capital X dash, it is nothing but derivative with respect to x, derivative of capital X with respect to x. So using this, so we can simplify this equation as, let me clean this first. We can simplify this equation as, sorry, not this one. You can simplify this equation as d capital X by capital X k small dx, right? Now let us integrate this. Now you see, if you integrate this, then what you gonna get? So then you will get log of capital X is equal to, k is constant, and integration of dx is x plus log of c1 is the constant. So again, if you solve this, then you will get the value of capital X is e to the power c1 into e to the power kx, right? So we have already done twice in the last two problems, first one and second equation, how we get the value of x. We have already done this, so I'm not going to repeat the same steps here. You can write directly if you know. Okay, once you get this form, just this term and this constant, take this constant c1 and e to the power this term, that will be the value of capital X. Remember that. Okay, so you can directly use that result. So similarly, you can now equate this part, 4 y dash by y is equal to k, right? This is equal to y dash by y k by 4, and if you integrate this, then what you will get, again log of capital Y is equal to k by 4 small y plus log of c2, right? So after using this del y dash, instead of y dash, if you use capital dx by, sorry, not capital dx, y dash is nothing but derivative of capital Y with respect to y, right? If you use this in this equation, then it becomes of this form: 1 by y d capital Y is equal to k by 4 d small y, and integrating this you will get this result, right? So hope you have understood this. Now solution of this one you can write directly. So y is equal to this constant c2 and e to the power this term k by 4, you can write directly k small y by 4, right? So if you now use these two values, use these two results, capital X and Y, in equation number 2. In this equation, u is equal to capital X dot y, so you will get the solution. So the solution is u, that is x into sorry, not t, here we have taken y, capital X capital Y. Now let us put the values of capital X and capital Y. So c1 e to the power kx into c2 e to the power ky by 4, and this can be written as c1 c2 e to the power kx plus k small y by 4. Let me write this one properly, cleanly. Okay, so c1 c2 e to the power kx plus ky by 4. So this is your answer. So hope you have understood this. Now let's move on to next question. Now this is question number 7. Here you can see, so what are scalar and vector fields? Give examples. So first question is, what are scalar and vector field? Give examples. So definition of the scalar field. Scalar field is defined as, suppose that to each point x comma y comma z of a region D in space, there corresponds a number phi x comma y comma z, then this phi is called a scalar function. Scalar function of position, and we say that scalar field phi, and we can say that scalar field phi has been defined on the region D, right? So this is the definition of scalar field, and you can take example. Temperature at any point within or on the earth at surface, on the earth's surface at a certain time defined as scalar field, defines a scalar field. Pause the video and note it. Okay, so now let me define the vector field. So first let me clean this. So vector field is defined as, suppose to each point of a region, to each point x comma y comma z of a region D in space there corresponds a vector capital V x comma y comma z, right? This is a vector. Then this vector V is called a vector function of position and we can say that a vector field V has been defined on the region D, right? And you can take the example. This example is suppose the velocity of at any point, the velocity at any point within a moving fluid, okay, is known at a certain time, then vector field is defined. Then a vector field is defined. So you can take this example. Okay, so now let's move on to B. Here we need to show that the grade of 1 by r is equal to minus vector r divided by r cube, right? So let me write it properly. So here we need to show grade 1 by r is equal to minus vector r divided by r cube. We need to show this, right? And in C, here we need to define divergence of vector r. That's it. So let's first show the B. Let me show B. Okay, so let me clean this first. So here you see, so this is the vector r, right? And r will be equal to this root over x square plus y square z square. Then 1 by r is given by this. So now you see divergence of del of 1 by r, grade of 1 by r, so can be written as del x of 1 by r I cap, del y of 1 by r j cap, then del z of 1 by r k cap. So let us find the derivative of 1 by r with respect to x first. So 1 by r is nothing but x square plus y square whole to the power 1 by 2. If you differentiate it, then with respect to x you will get minus half, and x square plus y square plus z square whole to the power minus 3 by 2. And if you see this is function of function, again you need to differentiate the terms within it inside the bracket. Then if you differentiate, derivative of x square will be twice x, and derivative of the remaining will be zeros. As this is partial derivative, we have to keep the other variable as constant. So here 2 cancels, so you can see, so 2 cancels, so we have got this result. Here this x square plus y square plus z square whole to the power minus 3/2 can be written as x square plus y square whole to the power minus half whole to the power 3. We can write that way, right? So now you see this term within the curly bracket, this part is nothing but 1 by r, so we can write minus x 1 by r cube. So now similarly you can find del y by del y of 1 by r. Just replace this x by y, then you will get the result, right? And similarly you can find partial derivative of 1 by r with respect to z. Just replace the y by z, this y is replaced by z, then you will get the result. Okay, now if you put these three values, here in this above equation, then you will get the result, right? Now let us take this common, minus 1 by r cube is taken common, then this is nothing but vector r, right? So this is vector r. So here you see this term inside the bracket, it is r vector. So this simplifies. If you simplify this, then you will get this result. So that's all what we need to prove, that grade of 1 by r is equal to this minus vector r by r cube. That's how we can prove. Now let's move on to the next part of this question, that is here you can see this is the C. Here we need to find the divergence of vector r. So let's move on to that. So here you see this is divergence of vector r. So del operator represents this, right? And vector r is this one. So we need to find a dot product of these two. If you find a dot product, then what are you gonna get? So we know that I cap and I cap, that's gonna give you 1, and del x of x will be 1, right? And similarly j cap will be again 1, del y of y will be 1 again, del z of z will be again 1, k cap, dot product is 1. So that's why we have got 1 plus 1 plus 1, that is equal to 3. That's it. So this is the question number 8. Here, what is the geometrical interpretation of gradient of a scalar function? So we need to write the geometrical meaning, physical meaning of gradient of a scalar function. So let me write the answer here. Geometrical interpretation of gradient of a scalar function. Let us suppose we have a scalar function phi represented by a level surface, that is phi, which is a function of x, y and z, is equal to c, that is constant. C is constant here. So now let us move along the surface through a distance dr from point P to Q. Then the change in phi going from P to Q, okay, this is the surface going from P to Q, the change in phi, and this is the distance dr, will be given by del phi. So del phi represents, you know, the del operator that gives del by del x I cap, del by del y j cap, and del by del z k cap, right? So this gives variation or change along x-axis, y-axis and z-axis. So it gives variation along x when y and z constant, variation along y when x and z constant, variation along z when x and y constant. So that gives the variation. Now you see, so this variation or this change differ depending on the direction of this del phi, depending on the angle between dr and del phi, right? So here you see this d phi, that's derivative of phi, that's going to be given by del phi dot dr, which can be written as magnitude of del phi, magnitude of del r cos theta, right? So here you see this will be greatest, this d phi, this that gives a change d phi this value of d phi will be greatest when the angle between del phi and del dr is 0, right? That means if they are parallel. So if you take the direction, if you move along this distance, if you find the del phi along this direction, in this direction, then you will get the change, you will get the greatest change. Okay, so when theta is equal to 0, so if d phi is equal to 0, now you see, then cos theta is equal to 0, which gives theta is equal to 90. So when this del phi is normal, right, then you will get minimum change. Okay, and this phi is normal to the surface. So this is the physical meaning of this this is the geometrical interpretation of gradient of a scalar function. So hope you have understood this. So remaining questions will be solved in the next 2 or 1 video. So in this video I have solved up to question number 8a. In part 1 I have solved from 1 to question number 4a. So I have started here from 4b, right? So hope you have understood, and if you have understood, please share with your friends, hit the thumbs up button, and if you like the video, hit the thumbs up button, and if you are new to my channel, please subscribe the channel and stay connected. So see you in the next video, third part. So hit the bell icon so that you get the notification when I will upload the next video. So thank you for watching.